Okay, in this section, which is trig substitution, I call it trig sub, we're going to be solving integrals that have the terms a squared minus x squared, a squared plus x squared, or x squared minus a squared. So any one of those three terms will appear in our integral, okay? So I want to first remind you of these integrals that we learned back in the previous modules, and that is integrals that lead to inverse trig functions. So the first integral is the integral of dx over the square root of a squared minus x squared. If you remember, that's the sine inverse of x over a plus a constant. Then the second one is the integral of dx over a squared plus x squared. That one was 1 over a, the tan inverse of x over a plus a constant. And then the last one, which was dx over x times the square root of x squared minus a squared is equal to 1 over a secant inverse of the absolute value of x over a plus c. Okay, so what I want you to be able to associate are the following transformations. So all that is review. Okay, so the first transformation I want you to associate is whenever you see this a squared minus x squared here, I want you to think sine inverse. So a squared minus x squared, we're going to use the transformation that theta is the sine inverse of x over a, or we could write it as x over a is the sine of theta. And I hope you understand how to go back and forth from one to the other. Okay, the next one, we have a squared plus x squared, and that should be associated with tan inverse. So when you see a squared plus x squared, know that in your problem, you're going to have theta is the tan inverse of x over a, or x is equal to a tan theta. And then the last one is the secant inverse. So whenever you have x squared minus a squared in your integral, I want you to associate x squared minus a squared with secant inverse of x over a, where x over a is equal to the secant of theta. Okay, so now let's get going with our first problem. Okay. All right, so here's our first problem, and we are going to associate it with this information. And that is a squared minus x squared. Whenever we see this in an integral, we're going to use x over a is the sine inverse of theta. Okay, so I need a triangle. So I got a triangle already made for me, so I don't have to keep drawing one. You guys can draw triangles as you wish. Okay, so here's the first problem. All righty. Okay, so I see in this problem, I have 1 minus x squared. So that looks to me like an a squared minus x squared inside of my integral. So if I do that, then in this problem, I'm going to say here, a squared is indeed 1. So a will be 1 in this problem. Okay, and so where I have x over a is equal to the sine of theta, that tells me that x over 1 is the sine of theta. So I can go over to my triangle and draw theta, and x over 1 is the sine of theta, and that means this side is the square root of 1 minus x squared. Okay, any questions about that? Okay. All righty, so we have x is now equal to the sine of theta. So that takes care of this x and that. Up, I need dx. Okay, so dx is the cosine of theta d theta. So now I have my dx taken care of. And so the only thing I need left inside this integral is the square root of 1 minus x squared. So let's find that. So the square root of 1 minus x squared is the square root of 1 minus x squared is just sine squared theta. Okay, that's good. Because the square 1 minus sine squared is cosine squared. Notice this triangle is less than 90 degrees. So therefore, I have the square root of cosine squared theta, which is just cosine theta. So now I know everything. I know the square root of 1 minus x squared, it's cosine theta. I know what x is, it's sine theta, and I know what dx is. And so now I can do a complete substitution. And when I do a complete substitution, I am going to pick this integral up. Uh-oh. And I'm going to get the integral x cubed. Well, what was x? X was the sine of theta. So this is going to be the sine cubed of theta. Dx is cosine theta, d theta, and that is over the square root of 1 minus x squared, which we also know is cosine theta. Okay. So I've made a complete substitution. X cubed is sine cubed theta. Dx is cosine theta d theta. And square root of 1 minus x squared is cosine theta. Okay, so now I can divide this out. So this is just the integral of the sine cubed of theta d theta. All right, so now notice that I started off with x and I went from x to theta. And now I need to do my problem in theta. So how do I do this integral of sine cubed theta? This is an integral where the power of sine and cosine or cosine is odd. So what do you do when it's odd?
So it'd be sine squared times sine.
Okay, good.
This
So
is geometry.
therefore, I'm going to get the integral. I'm going to get the sine squared of theta times the sine of theta. So you peel off one of the odd ones. But then when you peel off one of the odd ones, remember the other one has to go. So if I keep one sign, the other ones have to go. So they become 1 minus cosine squared theta times the sine of theta d theta. Okay. So now I'm going to do a U substitution. So now I'm going to let U equal the cosine of theta and du equal to the negative sine of theta d theta. And then I get negative du is the sine of theta. Now notice I have given, let me do an insert here right now. Okay, so the problem started in X. So notice we went from X to theta and theta to U. Now, I didn't get a chance to put these pictures on here. I wish I had, so I'll just grab them from here. Copy. And then I will come over here, put it here, paste. Whoa, that's awfully big. And then I'm going to go here and copy and go back over here and paste. And that's also rather big, so I'm going to scrunch it up. Okay, so what's the difference between these two bicycles?
One look new and one look damaged.
One looks normal and one looks damaged. That's right. Okay, so how would you feel if you lent somebody this pristine bicycle and it came back looking like that?
I'd be highly upset.
You'd be highly upset. Okay, so that's what happens with these problems. If this problem is given to you in X and you have deformed it to become a theta and then transformed it again to become a U, you can't give me back the answer in U. You have to go back from U to theta and theta to X and give me my pristine bicycle back. Okay? So that's what I want you to be thinking when you're doing these problems. All right, so this becomes the integral of 1 minus u squared times negative du. So that is the integral. I can flip them and get u squared minus 1. So that gives me 1/3 u cubed minus u plus a constant. So now I know it feels like we're done because we put that plus c, but we're not. We have to take that u and put the theta back in. So this becomes 1/3 the cosine cubed of theta minus the cosine of theta
I was just joining from your phone, Johnny.
plus a constant.
I was just joining from your phone. Oh.
Okay. So now I have to go back to theta. So I need to go back to my problem. And when I go back up here, I see that the cosine of theta is the square root of 1 minus x squared. So now I got to go back to x. So this is 1/3 the square root of 1 minus x squared cubed minus the square root of 1 minus x squared plus a constant. And so the nice way to write it would be 1/3 times 1 minus x squared to the 3/2 power minus 1 minus x squared to the 1/2 power plus a constant. And so therefore I am now done. Uh-oh, I don't want the bicycle. I want, that's funny. I want this guy. This guy is equal to 1/3 times 1 minus x squared to the 3/2 power minus 1 minus x squared to the 1/2 power plus a constant. Okay. All done. Nice and beautiful. Any questions about that one? Okay. Oh, I'm going to the wrong place. I need no-go number 2. All righty, this is problem number 2. And problem number 2 seems to have a liking or similar form like this. So I have a squared plus x squared in my problem. I see it, there it is. So in that case, I'm going to use theta is the tan inverse of x over a, or I'm going to use x over a is the tangent of theta. Let me go grab my triangle because I'm going to need it. Okay. All right, so a squared is 4. So my a is 2. So I get x over 2 is the tangent of theta. So I come over here, there's theta, x over 2 is the tangent. So that means that this side is the square root of 4 plus x squared. Okay. All righty, so now I have x is equal to 2 times the tangent of theta. I know I need dx, so dx is 2 times the secant squared of theta d theta. Now I have to figure out what 4 plus x squared is. So 4 plus x squared is 4 plus x squared is 2 tangent of theta squared. So that's 4 plus 4 times the tangent of theta squared. I'm going to factor out a 4. And I'm going to get 1 plus tangent squared. And that was one of my formulas. That is secant squared of theta. Okay. That was right there. Okay. All righty. So now I can do a complete substitution because I have everything I need. Okay. So I get the integral dx, here it is. 2 times the secant squared of theta, d theta, and 4 plus x squared squared, okay? So 4 plus x squared is 4 secant squared theta squared, okay? So that is 4 over 2 over 16. So I'm going to get 1 over 8. The integral secant squared over secant to the 4th is 1 over secant squared. And 1 over secant squared, well, that's wonderful. That's just cosine squared. Okay, so here's my question. I want you guys to make the transformation for the cosine squared of theta while I take roll. Okay, so how do I do the integral of the cosine cubed? Cosine squared. Anybody remember, this is when the power of cosine and sine is even. So you just have to use a double angle formula. One over 8. And inside here, you have 1/2 times 1 plus the cosine of 2 theta d theta. Okay. So that gives you 1 over 16. When I integrate 1, I'm going to get theta. And when I integrate cosine 2 theta, I get 1/2 the sine of 2 theta plus a constant. And so now I have to figure out what to do with this sine of 2 theta. And that lends to another law. That is the sine of 2 theta is 2 times the sine of theta cosine theta. Okay, so that has to pop in there. Okay, so when we put that in there, we end up with 1 over 16 theta plus the 2 and the 1/2 are going to divide out, and I'm going to get the sine of theta times the cosine of theta plus a constant. Okay, remember now, it looks great. We got a plus C, but this is the bicycle that doesn't look like it was when I gave it to you. So we got to go back. So go back up to the problem. We got to find theta. So theta is somewhere up there. It is. Theta is the tan inverse of x over a. So we have that. And let's see. Okay. I don't see the sine of theta or the cosine of theta anywhere in our problem. So we're going to have to use a triangle. That's why the triangle is there. So when we go to use the triangle, the sine of theta is the opposite over the hypotenuse, which is x over the square root of 4 plus x squared. And the cosine of theta is the adjacent over the hypotenuse, which is 2 over the square root of 4 plus x squared. So it is very important that you have a triangle so that you can see what you're looking for. Okay, so we're going to use the following. The first, that theta is the tan inverse of x over a, and a for this problem was 4. We also know that the sine of theta was x over the square root of, now let me remember, 16 minus x squared? No, 4 plus x squared. So this is wrong. A is 2. And the cosine of theta is 2 over the square root of 4 plus x squared. Okay. So this gives me 1 over 16. Theta is the tan inverse of x over 2, plus the sine of theta is x over the square root of 4 plus x squared times 2 over the square root of 4 plus x squared plus constant. And so now I'm done. So now I can put this here. And this is, I need to bring that down just a hair. Okay. This is equal to 1 over 16. That feels weird. Tan inverse of x over 2 plus 2x over 4 plus x squared plus a constant. That's the answer to the problem. And I'm done. Okay, any questions? So obviously, if we've done a sine inverse and a tan inverse, we're going to do a secant inverse. Okay, number 3 looks like this, and I need my triangle. Oh, I also need my formula that I told you guys. Okay. All right, so this is a secant inverse one. The reason why I know is because it's x squared minus a squared. It's not a squared minus x squared. So x squared minus a squared, here, a squared is 25. So x equals 5. All right, so I get x over a, x over 5 is equal to the secant of theta. So x is equal to 5 times the secant of theta. So x over 5 is secant. So that's x over 5 is secant, which, so then this side becomes the square root of 25. No, what did I just do? That was cosine. Secant is this over that. So this is x squared minus 25. So if you can figure it out as you're doing it, like I just put in the cosine instead of the secant because it was upside down. Then I figured out this can't be right. So now it's right. So x over 5 is the secant of theta. So now I need dx and I need x squared minus 25. So dx is 5 times the secant of theta, the tangent of theta, d theta, and the square root. Let's see how this works. So what is it? The square root of x squared minus 25 is equal to, oh, that looks nothing like what I'm trying to write. Okay, that looks better. Is equal to the square root and inside the square root x squared. So x squared is 5 times the secant of theta squared minus 25. It still don't look right, but that's okay. I tried. It didn't work. I don't know why it doesn't work for me, but that's all right. Y'all know I like some perfect notes. I have a hard time with sloppy stuff. Okay, so this is 5. Oh, what am I doing? X squared minus 25. Is equal to the square root of 5 times the secant of theta squared minus 25. So inside the square root, I get 25 secant squared theta minus 25. Okay, so let's keep going. It's not too bad. We can factor out the 25 and get secant squared theta minus 1. Okay, so now we're done. Square root of 25 is 5. And then secant squared minus 1 is tangent squared, and then the square root of tangent squared is tangent. Okay, so we're all done. So now we can put everything in. All righty. All right, we get the integral. Square root of x squared minus 25 is 5 times the tangent of theta. Dx is 5 times the secant of theta, tangent of theta, d theta. And then the denominator x is 5 times the secant of theta. Okay. So what cancels? Well, this 2, this 5 and that 5, and this secant and that secant. Okay, very good. So that leaves me 5 times the integral of tangent squared theta d theta. Okay, how do I integrate that? How do I integrate tangent squared theta? Anybody? We're going to trade tangents for secants. 5 times the integral of secant squared theta minus 1 d theta. So that's 5. Integral of tangent, secant squared is tangent minus theta plus c. Okay, so now I know to find the tangent of theta. So the tangent of theta is this over that. Okay, it is opposite over adjacent. So now I know the tangent. And I also know theta. Theta is right here. It's the secant inverse of x over a. Okay, so we are ready to fill this in. So this is 5. Tangent is the square root of x squared minus 25 over 5 minus, and this is the secant inverse of x over 5 plus a constant. So we are done. I'm going to divide that 5 and get the square root of x squared minus 25 minus 5, the secant inverse of x over 5 plus a constant. And then it's an answer, so I'm just going to square it in blue, and there you go. Let's make that look more like a 5. There we go. Okay. Any questions about these? Because the next one I'm getting ready to do is much more difficult. So I know that there are a lot of formulas that you guys, this is a formula sheet, man. You have to, here we had to use sine of 2 theta. That was a new formula for us. We've used the secant squared is 1 plus tangent squared a couple of times. We've used cosine squared is 1/2 times 1 plus the cosine. I don't know where that one was, right here. 1 plus the cosine of 2 theta. We had to use that one. So there are a lot of formulas that we needed for this, these problems. Okay. I see no questions. All right, I think I'm just talking to a bunch of empty rooms. You guys were logged in, but you took off. And you're somewhere else. Okay. This one's a little more involved. All right, notice that I have 16 minus 9x squared. Well, that kind of looks like 6a squared minus x squared. It really looks more like a squared minus u squared. So that's what that looks more like, is an a squared minus u squared problem. But an a squared minus u squared problem, I'm gonna do the same way as I would an a squared minus x squared problem. Okay, so if I let a squared equals 16 and u squared equal 9 minus x squared, equal 9x squared. Then I get a is equal to 4. And I get u is 3x. So du is 3 dx. Dx is 1/3 du. I need x. Okay, well, I'm going to get x from here. So x is going to equal u over 3. Oh, actually, I didn't need x. I need x squared. So let's forget that. We don't need that. We need x squared. So let's come to this one. All right, so x squared is equal to u squared over 9. Okay, so now I think I have everything. Okay, so now I have dx. So everybody go ahead and put everything in and simplify it and tell me what you get. Let me let y'all do that. Go ahead and put everything in and tell me what you get at the end. All right, so what'd you get?
So I believe it's 1/3. 1/3 the integral of 1/, u squared divided u squared divided by 9 multiplied by the square root of a squared minus u squared. And then du at the end of all that.
Okay,
But
that's-
actually, one quick question, could you, since we have, technically you have 1/9 in the denominator, could you also multiply that by 9?
yes,
So then actually we could put that multiplied by 9 outside the integral. And so 9 times 1/3 just equals 3.
and that's the right integral.
All right.
Awesome. Okay, so that's the new integral. Okay, that is the new integral. So if we can solve this new integral and then put everything back in, we're good. All right, so the new integral is the integral oh, I forgot my 3. 3 times the integral du over the top, and then u squared. That's correct. And then we have the square root of a squared minus u squared. Perfect. Yay. Okay, so now let me grab my triangle here. And I'm going to move it down here with the new problem. Okay, so for now, the new problem, u over a is going to be the sine of theta. Okay. So u is a sine theta. And I'm even going to be as bold as to say u is, what is a? A is 4 sine theta. So u over 4 is the sine of theta. So this side over here is the square root of 16 minus u squared. Okay. Du is 4 cosine theta. Oh, my goodness. The letters are running together. 4 cosine theta d theta. And then I need the square root. So remember now, this is the integral of 3 times du over u squared, the square root of 16 minus u squared. Okay, so therefore I need the square root of 16 minus u squared. So that's the square root of 16 minus u squared is 16 sine squared theta. So I put u right in there. Okay. So that's the square root of 16 times 1 minus the sine squared of theta. 1 minus sine squared is cosine squared, and the angle is less than 90, so the square root of cosine squared is cosine, so this just becomes 4 cosine theta. All righty. So let's take this integral and substitute everything in. All right, so in the place of a squared, I'm going to put 16. Okay. So this is going to be 3 integral du, up there it is, 4 cosine theta. D theta. I need u squared. So u squared is right here, 16 sine squared theta. And then I need the square root of 16 minus u squared, and that is 4 cosine theta. And so now my integral, my 4's divide out, my cosine thetas divide out. I get 3 over 16. The integral and sine squared in the denominator is cosecant squared in the numerator. How do you integrate cosecant squared? Integral of cosecant squared is negative cotangent of theta plus a constant. Okay, well, that looks pretty good. Except for the fact that I'm in theta, my original problem was giving to me an x, and I went from x to u to theta. So now I got to go from theta to u back to x. So now if I go back to my triangle, I need to look for the cotangent. This is negative 3 over 16. How do you find the cotangent? The cotangent is 1 over the tangent. So if the tangent is that, so the cotangent is going to be this over this. This is why I say draw the triangle. It helps. Okay, so I get the square root of 16 minus u squared. Wasn't that cute? Divided by u. Okay, plus a constant. So I went from theta to u. So now I got to go from u to x. Okay, so this is negative 3 over 16. The square root of 16 minus u squared is 9x squared. And u is 3x plus a constant. And so now I am done. I'm going to go back and grab my original problem. Here's the original. Wow, we were all the way back there. You kind of almost lose track. So there's the original. It is equal to, the 3's will divide out. And so I get the square root of 16 minus 9x squared divided by 16x. It is negative plus a constant. And I'm all done. Okay, any questions? All right, I have one more. I'm gonna let you guys set this one up. Okay. Okay, what kind of problem is this one?
A tan inverse.
Yes, tan inverse. Okay. So a squared is going to be 1, and u squared is going to be 4x squared. So a is 1, and u is 2x. And I need a triangle. Okay, what do we do? What do you do? I hope this is not one of the ones that turns out to be, let me make sure this is not one of the ones that turns out to be, oh no, this is a beautiful one. Oh no, it is not. This is the one, oh, this is the hard case. Okay. Let me find another problem. This is the hard case. Let me see. If I put, I'm trying to see if there's a way I can make this nice. Okay, I can't find any way to make this a nice one, so I'm going to find a different one. I definitely, this one works out to the case with the reduction that I didn't want to do. So let me find a different one. Did I do that one? This is an easy one. This one's an easy one. We're gonna change this. All right, it won't let me. Okay, so let's just write a whole new problem. So integral okay, this one is doable. Much easier. Much easier. Okay. All right, so we're gonna get rid of this one. And we're gonna slide this one right up on here. And notice nothing has changed. Okay, so now we're going to have a squared plus u squared in the problem. So that says that u over a is the tangent of theta. All right, so u over 1 is the tangent of theta. So u over 1 is the tangent of theta. So that means this side square root of 1 plus u squared. Okay, so make your substitutions. Tell me what you get. Anybody get anything yet? Du is secant squared theta. D theta. And the square root of 1 plus u squared is the square root of 1 plus the tangent squared. Oh, that's easy. That's the square root of secant squared. So that's just secant theta. Okay, so what do you get for this problem? Oh, wrong one. Danielson, did you get a substitution yet?
No, I'm a little, sorry, I got a little lost.
You got a little lost?
Yes, not lost, but I got behind, so I had to catch up.
Oh, okay. Anybody else? I know Danielson's working. Anybody else? I get 1 over the square root of 1 plus u squared. Oh, I forgot. Yeah, this becomes integral of 1 square root of 1 plus u squared. And then dx becomes 1/2 du. So I get 1/2 the integral of du over the square root of 1 plus u squared. So now what's du? Du, we already said, was tangent of theta. And then d theta,
Wait, wasn't du secant squared of theta?
I'm sorry, du is secant squared theta, you are correct. And then that square root is also secant theta. So this is a nice integral. This is just 1/2 the integral of the secant of theta, d theta. What's the integral of secant theta? We did this one.
Natural log of secant theta plus tan theta.
That's right.
Absolute value.
Okay, now we're still stuck in theta. We got to go back to our triangle. From our theta here, secant theta is the square root of 1 plus u squared. Tangent theta was just u. So secant theta was the square root of 1 plus u squared. And the tangent theta is just u. Okay, now we gotta go back. What was u? U is the tangent of theta. No. U is 2x. So this is 1/2 the log of the absolute value, stop. Of the square root of 1 plus 4x squared plus 2x plus a constant. Okay. That's supposed to be an absolute value. All right, guys, all done for today.